That was really good. Okay, on Wednesdays we are pink the 18th of November. SWBA, you guys will be able to apply. Wrong one. Use angle measures, postulates, and theorems to prove lines parallel. Okay, you thought we were done with proofs. You were wrong. Okay.
We're never going to be done with them.
Exactly. In the last section, we started with parallel lines and we worked toward angles. Okay, we started with having parallel lines and we said, hey, if we know these lines are parallel, we can know these angles are congruent, these angles are supplementary. Now we're going the other way around. We're going to start with angles. We're going to start with angles and we're going to work towards parallel lines using the angle relationships.
How many sections are in this chapter?
4.
Are you sure there's not a good one? So are we taking
Yes.
our test with Thursday, right?
No, well, we would, but Thursday is Thanksgiving.
Oh.
So we're looking at taking it when we get back. I'm not going to give you guys like the test the day you get back, so that's a little rude.
It might not even be. Why
So.
not? That'd be funny.
I mean, Dylan, you're not going to do well anyway, so it doesn't matter. Okay. Okay, I don't know about that. Anyway, yes. Then we'll adjust. Okay. Voice off, voice off. Okay. So, we have some different postulates and theories we're going to use, okay? Converse of corresponding angles postulate. Go and write this part down, this blue part down. Go and write that part down, okay? You don't have that written down in yours. Go and write that down above the first set of stars.
Well, I don't know where you're at.
Okay? This is...
I know where he's at, but I don't know where he's at.
Seth?
Hey,
It's a board, so look at your paper and put two and two together.
write this part down.
Actually, that's question 1.
Huh?
Okay, anyway. Converse. What does converse mean? We talked about this in chapter 2.
Switch.
You switch the order, okay? What was first is now last. What was last is now first, okay? You switch the order, okay? That's like saying, if I live in Omaha, then I live in Nebraska. Okay, converse would be if I live in Nebraska, then I live in Omaha. Now, sometimes the converse isn't true, and sometimes the converse was true. Do you guys remember that? Okay, sometimes it is true switch around, sometimes it's not. Now, these converses that we're going to talk about are going to be true. Now, the original corresponding angles postulate said, hey, if we have two parallel lines cut by a transversal, then corresponding angles are congruent. If we have two parallel lines cut by a transversal, then corresponding angles are congruent. So the converse is going to take that, we're going to switch it around. We're going to say, hey, if two lines are cut by a transversal, we don't know if they're parallel yet though, but if we have two lines cut by a transversal and corresponding angles, I'm going to shorten it to corresponding angles are congruent, then the lines are parallel. So we're switching the order around, okay? So instead of saying lines are parallel, angles are congruent, we're saying, switching around, angles are congruent, so the lines must be parallel. Does that kind of make sense? The converse idea like we did before?
So
Switching the order. What was that?
Are these always going to be true?
Yeah, these converses are true, okay? These are going to be postulates and theorems, meaning that these are 100% true, okay? To where if you have corresponding angles congruent, you can know that the two lines cut by the transversal are in fact parallel. So in this picture with these stars, okay, over here to the right, if I pick this top left star, look how nicely I'm coloring this one in right now. Okay, if I pick this top left star, which other star would be a corresponding angle to it?
The bottom left.
Yeah, bottom. No,
Bottom right. The top left star of the bottom.
Yeah.
The top left star of the bottom. Corresponding angles are in the same position at the other intersection.
Oh, that's wonderful.
Mr. Coswell, this morning when Tyler and I were working on this,
Yeah.
we called those four-way stops, like a four-way stop sign.
Oh, yeah.
I don't know if that'll help.
Yeah, they're kind of like a four-way stop sign each intersection. They're both in the same spot at that four-way stop sign. What's up? No.
There's like 10 to 5 stops.
That's ridiculous. Alrighty. So, we're saying if we know these two angles, those two red stars, if we were to know those two were congruent, then we could use the converse of the corresponding angles postulate to prove the lines parallel. If that was the case, we could prove the lines parallel. Okay? We're going to go through a lot of different Converse. You notice how there's a lot of different of these same, like they almost look identical on every spot. Okay, we're going to go on to the next one. Go ahead and write in converse of alternate interior angles theorem. Now, if you want to shorten this down, guys, you totally can. Conv of alt int angles thum. THM, okay? Now if it doesn't make sense to you to shorten it down, write it out. But if you would rather shorten it down and it makes sense to you, then go ahead and do that. Okay, Gregory.
What's supposed to go on that line? Did you put anything?
On the previous one?
Yes.
Yes. On the previous one, we had corresponding angles are congruent. So the first blank was...
No, he's talking about this.
Oh, the long line. Those are dividing sections between each one. Great question.
You sound like when you do that, when you're like, you know?
Yeah.
You sound like when you're skipping to like a VHS and it's like...
Having a stroke.
Kung Fu Panda.
Yes. Conv of alt int angles them.
Yeah, you
Okay.
sound like you're like... You sound like you're glitching.
So, if two lines are cut by a transversal, and this time we're using alternate interior angles. Does it make sense that we're using alternate interior angles when it's the converse of the alternate interior angles theorem? It makes sense to me. Alternate interior angles, okay? Two lines are cut by a transversal, and alternate interior angles are congruent, then the lines would be parallel.
So if they're not congruent, then it's both.
So if they're not congruent, then the second part is not true. So with if-then statements, okay, the first part's true, we can know the second part's true on this. Now, if I choose maybe this top left one star,
Bottom right or top right? Bottom star.
which one would be the alternate interior angle with this? Okay, Elizabeth.
Bottom left.
Star next to D.
The star next to D, the bottom right one.
Guys, stop talking.
It alternates sides of the transversal, and they are both interior, these two parallel lines. Questions on this? So if we happen to know that those two angles were congruent, then we could prove the lines parallel using the converse. The regular alternate interior angles theorem proves the angles congruent by using parallel lines. This one goes the other way around. Proves parallel lines by using angles. Seth.
So is this as far as inverse and converse ever found each other?
Yes. I like it. Bringing it back, Seth. Okay. Converse of alternate exterior angles theorem. Okay. So
Same thing, except it says exterior.
conv of alt x angles thum. And Seth made a good point here. This is probably going to be the same thing, except for it says exterior instead of interior, right? So go and write that down the title if you haven't already. Go and write down the title for the section if you haven't already. Okay. That little blue, okay, that I have in there. Yes.
How I remember exterior is like they're exiting note package.
For what?
For exterior exiting.
Exiting. There you go. Exterior, exiting, you're going out. I like that.
Mr. Costa,
What's up?
when you're doing the con of alt x, it reminds me of like when we had to restart the Zoom meeting like 4 times so your Wi-Fi would work.
Oh, yes. Yeah, rip in peace.
That's what the chapter was.
Yeah.
Rip in peace.
Yeah, RIP in peace.
What does
Rest
that
in
mean?
peace in peace.
I was tracking it.
If two lines are cut by a transversal and what type of angles?
Alternate exterior.
Alternate exterior.
Congruent.
Are congruent.
I did X and
Then the lines are parallel. We'll switch up this time. Let's say I do the top right.
And then bottom left.
Okay. The other one would in fact be the bottom left, the alternate sides of the transversal.
or you could have done the top left and bottom right.
Or I could have done the top left and the bottom right. Okay. Questions on that?
Maybe on Wednesday.
Gregory.
I don't know what I'm doing. Hang out wrong. Like I don't.
No, I don't hang out with you. No one's in my class.
Wait, what?
I got it.
Actually?
Yeah, I do.
Okay.
Because I thought I was coloring the wrong. I thought I was on the wrong section. The wrong part.
Gotcha. Okay. This last one's going to be the last star on this page. We still have one more after that, but it'll be the last star on this page. Yes, Bailey.
I'm just saying,
There you go. Converse of same side interior angles. That'd be funny, Bailey. I do choose it a little bit more on Wednesdays than I do other days. Reminder for same side, we can do S-S if you want. So I underline the S there as well. On this one, if two lines are cut by a transversal and blank blank angles, what are you thinking? What kind of angles? Same side interior.
Oh shoot, I thought I was gonna pull a dowel.
Same side interior angles are blank, then the lines are parallel.
Wait, I need to put this down.
Supplementary. Same side interior angles are supplementary.
Supply. Sup. Not much.
So let's say I put this top left one for these 4 stars. And I just picked one randomly. You could pick any of these 4. Which one would be the same side interior angles with that? Presley? Yeah. The bottom left one, the one by letter C. Or point C, I should say.
I mean, it's still a letter, so you
Next one's gonna be the same thing except for
Okay? They're on the same side of the transversal, and they're both interior. There's 2 parallel lines. If we recall, same side interior, SS.
S.
Supplementary, SSS. If you flip the page, you notice there's a little page break in here between the 2, okay? You just have to flip the page to get to it.
That's crazy.
And we can start writing down conv of same side or xed angles thumb. Yes, outerior.
I'd like going down and out to your fingers.
If 2 lines are cut by a transversal and what kind of angles?
Supplementary.
Same side exterior angles are what, Seth?
They are exterior. Supplementary.
Supplementary. Then the lines are parallel. So let's say I pick the top right one just to change things up a bit. Kev Dog. Which one's my other same side exterior angle with that? Bottom right, nailed it. Same side of the transversal, also exterior. Questions on that at all? All right. So, once again, like I was saying, the regular theorems, okay, these are all converses of regular theorems we had, okay? The regular theorems start with parallel lines, end up with angles being congruent or supplementary. Now, to me, it makes sense that the regular angles theorem would deal with angles being something, because you have angles in the name. So the purpose is that it's dealing with angles. Now, when you make the converse, though, that's when you switch around. So the converse now deals with parallel lines. You're trying to prove lines parallel. The next slide here. Name the angle relationship between these 2 angles and find the value of x, which will make lines A and B parallel. So, what kind of angles are these on the top left one? What kind of are these 2 angles? Okay, they are on the same side. Are they both interior, both exterior?
They're neither.
Gregory, what do you think they are?
Converse of corresponding angle postulate.
Okay, so we would use the converse of corresponding angles postulate to try and prove these lines parallel. What type of angles are these? Corresponding angles. So our answer to what type they are is corresponding angles. So name the angle relationship, corresponding angles. Now, if these corresponding angles are congruent, then the lines would be parallel. If these angles are congruent, then the lines would be parallel. So if these angles were congruent, what would be an equation I could set up? Seth?
3x plus 60 equals
Not quite. Gregory?
3x equals 60.
Congruent means set them equal. 3x would equal 60, okay? Now, if these lines are parallel, 3x will equal 60.
divide 60. 3.
Divide by 3.
No, divide by 60 for sure.
So, if x is 20, these 2 lines would be parallel because the corresponding angles will be congruent. Now let's say x is anything other than 20. If x is something else than 20, are these two angles going to be congruent? No, and then these lines would not be parallel. But as long as x is 20, these would be parallel. So our question was asking, name the angle relationship. We did, corresponding angles. And find the value of x, which will make these lines parallel. Well, if x is 20, they will be parallel. Questions on that?
Why does it look like on the fourth one we did something bad we had to delete?
Yes, I had to cover something up, but I still need to change that again, actually.
It doesn't look like your
Let's look at the top right one. What type of angles are these? Okay, let's go with Elizabeth.
Same side interior.
They are same side interior angles.
How did I?
Okay, now if the same side interior angles, what would they have to be in order for these lines to be parallel? Okay, Elizabeth will double down with you. Supplementary. So what would my equation have to be here? Okay, I'm going to go with Seth this time.
You have to have 2x plus 80 equals 100.
Yeah, so if these lines are parallel, 2x plus 80 would have to equal 180. We don't know if they are or not, but we're saying what would x be if they are?
100.
So,
50.
subtract 80,
Actually, 50.
2x equals 100,
50 down. I realize it's now.
divide by 2, and if x is 50, then those two angles, those same side interior angles, are supplementary. If the same side interior angles are supplementary, we can use the converse of same side interior angles theorem to say, hey, these lines would be parallel. If x is anything else, would these angles be supplementary? No, if x is even 51 or 49 even, okay, then it would not be supplementary anymore. And then the lines would not be parallel. But as long as it's 50, it would be. Questions on that? Okay.
Why?
This bottom left one, Gregory.
Alternate interior angles.
Nailed it. They are alternate interior angles. Okay. They alternate sides of that transversal, and they are both interior of these two parallel lines, or these two lines. We don't know if they're parallel. And we're saying, for what value of x will these two lines be parallel? Well, what equation do we set up? If we're finding x, we need an equation. Okay. Maybe we put that together yet. I'm not sure. Okay. If we're finding x, we need to make an equation to do so. So what kind of equation could we make to tell what x would be for these lines to be parallel? Gregory.
Parentheses x minus 20 degrees plus 70 degrees.
Not quite. Alternate interior angles have to be what for the lines to be parallel? Go ahead, Presley.
Would it be x minus 20 equals 70?
It would be equal 70, okay? If they're congruent, then the lines will be parallel. Because if the lines were parallel, then these angles were congruent to begin with. So this is our equation, and we would add 20. And you don't necessarily need the parentheses there, but I like that Gregory was just careful. X equals 90. So if x is 90,
Gregory's name comes wrong.
he asked me to call him one time.
You were saying that
You
there.
realized it was a fire name.
Okay.
Not wrong.
So if x is 90, then these angles both measure 70, so they're both congruent. And then if they're congruent, we can use the converse of alternate exterior angles theorem to prove the lines parallel. If x is anything other than 90, are these two angles congruent? No. So if x is anything other than 90, are these two lines parallel? No. Because these alternate interior angles, have to be congruent in order for the lines to be parallel. Questions on that? Alrighty. Let's look at this bottom right-hand one. What type of angles are these? Okay. I'm going to call on someone new for this one. Presley.
Alternate exterior.
Nailed it. Alternate exterior angles. They are alternating the sides of the transversal, and they are both exterior of these two lines. I keep saying parallel lines. They are exterior of these two lines. Now, alternate exterior angles would have to be what for the lines to be parallel? Elizabeth.
Corresponding.
Not corresponding. I think you're thinking of a different C word.
Oh my gosh, my brain is congruent.
Congruent. So if these angles are congruent, then the lines will be parallel. If they're not congruent, lines will not be parallel. Gregory, what's my equation?
4x minus 22 equals 3x minus 17.
Yeah, we set them equal. Congruent, cabo should be going off in our head to tell us to set them equal. So we'd solve this equation by subtracting 3x from each side. X minus 22 is equal to negative 17. Add 22. X equal to 5. So if x is 5, these two angles are congruent. And if alternate exterior angles are congruent, the lines are parallel by the converse of the alternate exterior angles theorem. Now, technically, this is actually a really bad question, the bottom right one, because if we were to plug the angles back in, you get a negative angle measure, which is not a thing. So I need to change up those numbers.
You know what they say?
No, I don't. Do you?
Yeah.
What do they say?
You know I pulled
No, it comes out negative. It comes out to be a -2 for both.
You know why penguins win the fight against the polar bears?
Why?
Because fight or flight kicked in. I thought that earlier and it was.
It's so funny.
I've been snickering about it all class.
That is so stupid.
I laughed so hard when he told me that the first time.
You turn the front facing camera on.
But if you're,
Yeah.
So if you are,
well, I wanted to make it.
you have x minus 22 equals negative 17.
Well, no. So x equals 5. But if you were to plug 5 back into the angles, it'd come out to be -2, yeah. Yeah.
I'm sorry.
You're good. All right, let's do some proofs. Right? Woo, proofs! Okay, Kevin's excited.
I don't want to do this
Kevin told me the other day, okay, he was in here, he was just hanging out with me, because I'm his favorite Mr. Costle. And he was like, Mr. Costle, I'm like, what's up, Kevin? And he's like, hey, you're my favorite Mr. Costle. I'm like, hey, thanks, you're my favorite Kevin Winscott. This all really happened, okay, believe it or not, okay? And then he's like, hey, you know what I really miss? I'm like, what's that? Proofs. I'm like, all right, I'll put some in for you, okay?
Why do you do this to us?
Yeah, Kevin, did that not happen?
No means a don't.
That happened, right?
Yeah.
Okay. Anyway,
I don't know, I smell a little.
I mean, she can yell if she wants to.
That sucks.
what if I tell you it's just a 2-stepper?
Oh shoot.
You're not getting very far.
So down. I think.
All right.
That was fun.
Now we have 3 freebies here out of the 4 spots.
Given.
What's one of our freebies, Bailey?
Given.
Where do I put given?
Reason.
Reason, which one? 1. The first reason is always given to us. Okay? Raise your hand for another freebie. Okay, Ryan.
Line L is parallel to line N.
Yeah, and where do I put that?
The second statement.
Nailed it. The second statement is what we're trying to prove. Line L is parallel to line N, okay? And what's my other freebie, Presley?
The first statement.
The first statement, what is that?
Angle A is congruent to angle 2.
Yeah, angle A is congruent to angle 2. It's what we're given.
Wait, what does that count as?
This is disappointing.
No, what are you trying to say, buddy?
Never mind.
Actually?
Yeah.
Okay.
No, I'm being serious.
Okay.
Because you said we have 3 freebies, but what's that count as? That's what I was saying.
Hold on.
Oh, I mean, I would say each of those 4 spots, 4 blanks, 1, 1, 1, 2, or 1, 2, 1, 2. I count that as 4 spots. So 3 of the 4 are freebies. We know those already. So guys, do you have to know anything about what we're doing right now in order to get 3 out of 4 points correct on this?
No.
Okay, big hint. Seth, put the book away. I don't want to see these blank on a test. Like, seriously, okay? I see some of these blank on a test every year. And it makes me so sad. Because there's some freebies every time. You don't have to know the problem at all, even to get some free points. All right, let's mark some information. Angle 2 and angle 8 congruent. Please stop. Okay. Angles 2 and angle 8 are congruent. Well, what type of angles are these? Alternate exterior. So, if alternate exterior angles are congruent, which they are here, can we prove the lines parallel? Yeah, how do we do that? We do the converse of the alternate exterior angles theorem.
Oh, it looks like an H. Exterior angles.
What?
It's a con of exterior angles.
Gotcha. It does kind of look like an H.
Mr. Trump.
Okay. Yes.
American history.
Okay.
What?
yes.
American history.
Okay. So, because they are alternate exterior angles, we're going to use an alternate exterior angles theorem. Does that make sense to you guys or no? Okay. What type of angles are they? Alternate exterior angles. So what kind of theorem are we using? Alternate exterior angles theorem. Now, we use the converse because are we proving lines or angles?
Angles.
Wait, line.
We're proving lines.
Why is the smell sour?
So we're going to use the converse. Okay? Because we're proving lines, we're going to use the converse. Maybe even write that in, guys. Okay? That if you're proving lines, okay? Proving lines, that means you use the converse.
Yes, sir.
Okay? If you're proving angles, you always use the regular one. It has angles in the name, so the regular one, if you don't change anything, deals with angles. But if you do change something by making it the converse, that's when it deals with lines. Question on that first one. Okay? What if I tell you number 2 is also a two-stepper? No.
You're not getting very far.
Okay. Tristan, you want to give me a freebie on this one? And where does that go? Okay, where? The statement 1 or 2? I didn't hear that. What? 1, yeah. So angle 7 is supplementary to angle 2 is our first statement. That's a freebie. Whatever given's our first statement every time. Okay? Quentin, what's another freebie?
For reasons, number 1 is given.
Yeah, the first reason's always given. We have to start somewhere. Okay? And what's another freebie here, Bailey?
We basically have to write what we proved.
Okay, and where do we write that?
On number 2 for what it's statement.
Yeah, the last statement is always what we're trying to prove. Line L is parallel line and in this case. So, angle 7 and angle 2. Now, is there a way we can mark supplementary? No, we don't have a little arc thing, but we can circle the angles so we know which ones we're talking about. And I actually highly suggest that is marking the angles which we're talking about somehow. I wouldn't do arcs because that shows they're congruent, which they're not. But I would mark it somehow, okay? So now we say, well, what kind of angles are these? Okay, that's our first question every time. What kind of angles are these, okay? Elizabeth. Okay, we're going to use the converse because we're proving lines.
Same side exterior angles.
They are same side exterior angles, so we're using same side exterior angles theorem.
We can put this stuff on a test, right?
The abbreviations?
Yes.
Oh, yes.
Okay.
Oh my god.
Thank you.
Yeah, I wouldn't have you guys doing it. I wouldn't have you doing it now if you couldn't.
Not makes you do it all the way out.
Yeah, right? Test actually make it harder. Okay. No, okay, so these are same side exterior angles. So that's how we know which theorem we're using. And because we're proving lines, we're going to use the converse. And if same side exterior angles are supplementary, which they are, then yeah, the lines would be parallel. Question on this one. Okay, this one is a three-stepper.
You're gonna run into it eventually.
Thanks for asking, Bailey.
These aren't even like.
Yeah.
Good.
You're gonna get hurt
Their test about to take us over next chapter.
Bailey, let me know when you're good. Okay, this one's a three-stepper. Now, even on this three-stepper, we still have half of it as freebies. Okay, Gregory.
Should I give you 2 givens or 1?
Let's put them in one line, but you can give them both.
Okay, so for statement number 1,
Yep.
would be, angle 4 is 62, equals 62.
Okay.
And then for number 2 on statements is measurement of angle 5 equals length.
Okay, and we're actually going to put those in the same line. If you put them in different lines, this is actually a 4-step proof, okay? So you can put them in different lines if you want, but we'll actually have to add a step to do that. But if you put them in one step, then it's a 3-step proof. Okay.
Can I give you another one?
Go and give me a freebie.
Alright, so then, in statement, you put the proof in.
Where? Statement 2 or 3?
3.
3. The last statement is always what we're trying to prove. Line L is parallel to line N. Okay, Dylan.
Reasons number 1 is given.
Yep, the first reason is always given. And if we did put the second given in step 2 and made it 4 steps, then the second reason would also be given, right? Okay. Now we can mark this information that we're given. Measuring angle 4 is 62 degrees. And measuring angle 5 is 118 degrees. Now, do we notice anything special about those two measures by chance? We're given them, so we should probably look at them, okay? What do we notice that's special about those two, Ryan?
They both equal 180.
Yeah, they add up to 180. So what does that tell us about angles 4 and angle 5? What are they? Supplementary. So we can say in our next statement, angle 4 is supplementary to angle 5. And what tells us that we can go from math to words? Math to words is a definition. Definition of what? Supplementary angles.
Poke myself in the eye.
Why'd you do that?
Use our other note package for this.
Yep, so some of our old ones come back. Definition of supplementary angles. If two angles add up to 180, they're supplementary. That's what the definition is. That's what supplementary means. It's defined as that. Now, if we know angle 4 and angle 5 are supplementary, can we prove the two lines parallel?
Yep.
Yeah, Elizabeth, how can we do that?
Converse of same side and 3 angles here.
Nailed it. The converse, because we're proving lines, of the same side interior angles theorem. Now, Kenny, how did Elizabeth know that it was going to be the converse of the same side interior angles theorem compared to like the converse of a different theorem?
Well, because they're on the inside.
Okay, because
Inside of the inside.
yeah, because they're same side interior angles, right?
Yeah.
So you just pick whatever type of angles they are, okay? Questions on that? Okay. Let's move on to number 5.
This is gonna be a flip.
Okay, this is a 4-stepper.
Are we skipping 4?
Okay, we are skipping 4.
And 3.
How many
We
steps?
just did
How many
3.
steps is
So
4?
we just
4 is a 2-stepper.
What time you guys
You were
go?
gone for 2.
Wait, so how do you know like how many steps?
I'll tell you.
Or is this a 4 step?
There's 4 lines.
I'll be nice and tell you. Okay? Now, this is a 4-stepper if both givens are in the same step. Okay, if both givens are in the same step, it's 4. Otherwise, it's 5, okay? So, we have freebies. Okay, Ken, you want to give me one?
Given under reason for the first one.
Okay, very good. Ty, you want to give me another freebie?
And I'm guessing.
Okay, line M is parallel to line N.
I'm guessing it also goes with angle 2.
Yep.
Angle 3.
Very good. Angle 2 is going to angle 3. That's another freebie. Okay, that those two statements are given. Line M is parallel to line N, and angle 2 is going to angle 3.
Oh, wait.
What was that?
Not never mind.
If you put them on different steps, it's a 5-step proof. If you put them on the same, it's a 4-step proof.
That's why I thought it was 4 because we put something
No, this one's a little bit longer.
there.
This is possible you tricked us.
Get it now.
I don't think so. Presley,
How do you know how many?
You never lied, no?
steps there are? Yeah, I'll tell you. Yep. I will tell you how many steps there are. Okay? And I'll even say, hey, if you put both givens in this, it'll be this. If you don't, it'll be this. Okay? So I'll even tell you that. Okay? That way you don't have to guess. Okay? I want to be nice to you. I want to give you at least a structure of it. Okay? What would be another freebie here, though? Okay? Tyler.
Line A is congruent to B.
Okay, line A is parallel to line B. And where does that go?
4.
Okay, statement 4. Line A is parallel to line B. Now we have some information we can mark here, right? Okay, line M is parallel to line N. Christian, how do we mark parallel lines? We went over this earlier, right?
Yep.
Okay, how do we mark parallel lines?
Arrows.
Little arrow. One arrow on each marks them parallel. Now we're also told angles 2 is congruent to angle 3. We do that with arcs. Now, we're trying to get, big picture, we're trying to prove lines A and B parallel. Now to do that, we probably need some sort of angle relationship between lines A and B in order to use the converse, right? That's kind of what we've been doing. We've been using some angle relationship, and we've been using the converse. So the big tip I've been giving you guys with these when there's so many lines is to do what? Cover one up. So let's say I cover up this line real quick, okay? Line N. Don't actually write over it, but maybe put a pencil or a finger over it, okay? If we cover that up, what angles would we need to have a relationship between in order to know lines A and B are parallel? Okay, Ray?
3, and I think that's 1.
Yeah, angles 3 and angle 1. So we need some sort of relationship between angles 3 and angle 1. That's big picture what we're trying to get to. Okay? And now, yes, Gregory?
Can I say it?
Yeah, what were you going to say?
So, they're congruent.
Okay, angles 1 and 3, we need to prove them congruent. Okay? Because if those angles are congruent, then we can prove those two lines parallel. So that means our second to last step, guys, is going to be that angle 1 is congruent to angle 3. If we can prove angle 1 is congruent to angle 3, we can then use what to prove these lines parallel?
That angle 3 is congruent.
If we know those two angles were congruent,
Now we could use,
the converse
yeah.
of what? Someone other than Elizabeth. Seth.
Make sure.
The converse of. I don't know.
Okay, what type of angles are angles 1 and angle 3?
Alternate exterior angles.
Converse of alternate exterior angles theorem. Now, we're not done with this proof, are we, though? Okay? We're just kind of working backwards up. We're saying, hey, big picture, this is what we need. So is it okay to work this proof kind of out of order? Yes, it totally is. Okay? Because if we get to this point, if we get step 3 to be angles 1 is congruent to angle 3, we can finish off step 4 like that. Okay? Gregory?
I'm confused about number 4.
Yep.
Shouldn't that be for 3 and 1?
Okay, great question. So the regular alternate exterior angles theorem would prove angles congruent, right? Okay. But do we know right now that lines A and B are parallel? Before step 4, do we know that lines A and B are parallel? No. So we can't use those two parallel lines to prove anything about angles. Does that make more sense? What we're trying to do is actually the opposite of using congruent angles to prove the lines parallel, which is why it's the converse. So big picture, if angles 1 and 3 are congruent, which we're trying to get to, then lines A and B are going to be parallel. Now, is there some sort of other angle we can use in order to make angles 1 and 3 congruent? Like maybe we could say if angle 1 is congruent to a different angle. Let's say I maybe cover up a different line here. Okay, I keep trying to cover up different lines and see what happens. Okay, if I cover up line M, do I see any two angles I could do something with?
You gotta cover up line A.
No, I should cover up line A. Okay, I cover up line A. Do I see two angles? Angle 1 and angle 2. Okay. Do I see two parallel lines cut by a transversal?
Yes, sir.
Hey, that's awesome. We love two parallel lines cut by a transversal. That tells us we can do stuff. What are angles 1 and angle 2?
Alternate interior.
They're alternate interior angles. So what should alternate interior angles be when the lines are parallel, which they are? Alternate interior angles are what?
Corresponding.
Congruent. They were going to say, Elizabeth? Okay. So angle 1 is congruent to angle 2 because of the alternate interior angles theorem. Now wait, Mr. Cossel, why did you use the regular one here? I thought we're only using converses today.
That's what we're proving.
That's what we're proving lines. Well, we're proving angles in step 2, so we can use the regular one. We use the regular one to prove angles because it has angles in the name. When you attach the word converse, we're proving lines. Now, we're able to do that again because we know lines M and N are parallel. So we can mark this information on our picture. Angle 2 has one arc. Let's put one arc on angle M. Or on angle 1, excuse me.
That means
Now,
angle 1.
does it look on our picture like angles 1 and 3 should be congruent?
Yeah.
Yeah. Now, what property can tell us that even though we can't use the parallel lines? What can tell us if we see, hey, 3 arcs like that, if we see, hey, angle 2 is congruent to angle 3 and this. I heard a couple different answers. They're both correct. What do you say? Transitive. What do you say, Seth? Substitution. It could be either. Okay? If you use substitution, I need you to say what you're substituting. Otherwise, we can just use the transitive property and say transitive property. Okay? But if you want to use substitution, you have to say substitution property and say, in parentheses, what you're substituting. Say, hey, this is congruent to this. So now, does this kind of fill in our missing gap, so to speak? Now, you don't have to go through it backwards like we did. Okay? Sometimes that helps people to kind of work backwards and think big picture. What do I need to get to? Okay, what would be the next step before that, knowing what we've been doing? And sometimes it's going to help people to go frontwards and say, okay, well, here's what I know. Well, okay, if I know those 2 lines are parallel, well, now I can know angles 1 and 2 are congruent. Oh, now if I know that, I know these 2 are. And then, like, oh, okay, now I can solve it. Questions on that? Kind of a weird one. Okay. Again today? You worked Binky yesterday, too. Nice. Let's look at number 8. Bailey, you want to make that sound again? Okay. Number 8. This is a 5-stepper if you put both givens on the same line. So this is either 5 or 6, depending on how many steps you use for the givens. Okay, we still have 3 freebies, though. Out of these 10 spots, we still have 3 freebies. So even on a test, if you're intimidating by a 5-step proof, you can still get a few freebies, okay? Kenny, give me some.
Reasons. First. Given.
Okay, perfect. Okay, Elizabeth.
Statements first. Measure of angle 9 plus measure of angle 6 equals 180, comma, R is parallel to S.
Nice. Nailed it, okay? Dylan.
M is parallel to N for the last statement.
Very good.
Yeah, Dylan's one of
So let's go ahead and mark some things on our picture. Okay, I always am a supporter of that. Line R is parallel to line S. Okay, and we're trying to prove the other 2 lines are parallel. Now we know measure of angle 9 and measure of angle 6 are out of 180, right? Now wait, what's it mean if they add a 180? We said that a minute ago, it means something else. They're what? Supplementary. So we can say on statement 2, let's use that information right now. Angle 9 and angle 6 are supplementary. Okay, and what's our reasoning for that? How can we know that's true? Gregory?
Because they add up to 180.
Because they add up to 180. So what tells us that? That's not a reason, though. That's not a theorem. Add up to 180. Nailed it. Definition of supplementary. The definition is, hey, if they add up to 180, they're supplementary. If they're supplementary, they add up to 180. Okay? Okay, well, so we know those are supplementary. That's a good sign. And big picture again, we're trying to prove lines M and N parallel. So we need some sort of angle relationship in order to do that, right? Okay? And we probably need an angle relationship involving one of these 2 angles we know something about, right? Otherwise, it'd be pretty useless to know something about these. So we probably need something that we know something about these, okay? Dylan, you had your hand raised? Okay, never mind, you're taking it back, okay? So we need some sort of angle relationship. It needs to involve one of the 2 angles that we know something about already, okay? Gregory.
You can cover up the top line, the one that's...
Line N?
Yeah.
Okay, let's cover that up. So now, if we were to go, we know angles R and S are parallel, right? Okay. So, is there anything we can know with angle 6 maybe, since we're told something about angle 6 already? Okay, that might be helpful to continue on with that angle. Okay, is there anything we can know about angle 6 in another angle because lines R and S are parallel? And we have 2 parallel lines cut by a transversal here. Once we cover it, the picture is a little easier to see. Gregory?
I don't know if this is right, but
Angle 13.
Angle 13?
Yeah.
Okay, you can know something about that in angle 13. What could you know about angle 6 and angle 13?
They add up to 180.
They add up to 180, right? So we can know angle 6 and angle 13 are supplementary.
Waterless one.
And what tells us that those two angles are supplementary?
Definition of supplementary.
Nope. We're not told they add up to 180 first.
They're told they add up 20. They add
What kind of angles are these?
Oh, writing, or,
Same side.
Same side interior angles. They're on the same side of this transversal M. They're both on the top, and they're both interior of the two parallel lines. So the same side interior angles theorem tells us, hey, those are supplementary. So you know angles 6 and 13 are supplementary as well. So now, if angles 9 and 13 are both supplementary with angle 6, what could we know? Gregory?
You can cover up line R,
Okay, cover up line R. That might be a good idea.
and then 9 and 13 are supplementary.
Okay.
Or wait.
If those lines were parallel, we could say they're supplementary, right? Or it's not supplementary, but maybe something else. If the lines were parallel, we could say something, but do we know those lines are parallel right now? Okay, we'll get there in a moment then. Okay? Elizabeth, what were you thinking?
I was thinking of covering up line R and angle 13 and 11.
Okay, angles 13 and 11, okay. So we could. That would actually end up using more steps than we need right now, though. Okay? But I love that you're thinking something with that, okay? Now, if we know angle 6 is supplementary with two different angles, what can we know about angles 9 and 13? Gregory?
They're alternate exteriors.
Not alternate exterior, no. Okay.
Oh, same side.
They are on the same side of the transversal, but not same side angles, yes.
9 and 13
9 and 13 are
are corresponding.
corresponding. Now, do we know if they're congruent yet or not, though, from that? Because the lines aren't parallel. So that means we're probably going to use that in step 5, right? For reason 5, we're probably going to use the converse of corresponding angles theorem, or corresponding angles postulate. Excuse me, this one's a postulate. And that probably means step 4 is going to be something about angles 9 and 13 being congruent. Is there another way we can know angles 9 and 13 are congruent? Is there another way we can know angles 9 and 13 are congruent? Besides them being corresponding angles, which we can't use right now. We know the lines are parallel. Could we say that, hey, since they're both supplementary to the same angle, they have to be congruent to each other? Do you guys remember that math before? Okay. So let's say angle 6, I just randomly give a measure to it, okay? I'm going to say it's 30 degrees. What would angle 9 have to be? If angle 6, the measure of angle 6, is 30 degrees, what would the measure of angle 9 have to be?
150.
Yeah, it would have to be 150 degrees, because it's supplementary, right? Well, what would the measure of angle 13 have to be if it's also supplementary to 30 degrees?
150.
So what do we notice about angles 9 and 13? They have to be congruent. And that's because they're both supplementary to the same other angle. So
That means
we have this theorem called the
6 is 30.
congruent supplements theorem. The congruent supplements theorem, saying, hey, if two angles are supplementary to the same angle, the angles have to be congruent. Now, we could have gone through a different way of this as well. I left that very open-ended for you guys to kind of go through, because there's a totally crazy amount of different ways you could go through this. Okay, and let me kind of tell you about a different way you could have gone through it if you wanted. So just kind of pay attention to this, please, and thank you, okay? So I'm going to say dialed in for a few more moments here, please. And say, hey, okay. Well, if we know angles 9 and 6 are supplementary, let's say we cover up line N like we talked about earlier. And we go through and we say angle 6 is congruent to angle 14 because they're corresponding angles. So I use on step 3, I say angle 6 is congruent to angle 14 by the corresponding angles postulate. That's okay for me to do because we have two parallel lines cut by a transversal. Well, now I can say angles 14 and angles 9. Okay. Or excuse me, I can say angle... Oh, no, I couldn't use angle 14. My goodness. I'm a goof. I'm sorry. I'd have to use a different angle rather than angle 14. I messed up. I could use angle 6 and angle 16, for example. And I could say angle 6 is congruent to angle 16 because of the alternate interior angles theorem. And then I can say, okay, now that those are congruent, I could say, instead of angles 9 and angle 6 are supplementary, I could say angle 9 and angle 16 are supplementary. And I could substitute that in. Because angle 6 is congruent to angle 16. And then instead of the converse of the corresponding angles postulate, I can say, oh, well, if 16 and 9, those angles are supplementary, I can use the converse of same side exterior angles. So there's other ways we could go about it as well. There's a lot of different ways you can go about these, okay? Gregory.
There is nothing.
Yes.